In my last video, we were analyzing flood fill problem on LeetCode. Let's see an example for the same. For example, this is our image array, which is a 2D array. These are a value of SRSC and color corresponding to the numbers inside the image array and the variable color. Let's assume some actual colors for these numbers. If we apply this assumption on a grid, our image would look something like this. You can see the value of SR and SC. That means we have to start the flood fill at 1, 1 index, and the color we want to fill is 3, which is black. This is the 1, 1 index. You can see the value at 1, 1 is 1. So we have to convert all the neighboring nodes, including the same node, into our color of choice, which is 3. So this will become 3, this will become 3, this will become 3, this will become 3, this will become 3. You can see I only changed the horizontal and vertical neighbors as of now, but we have to continue this operation for the change nodes, taking them as input as well. So for this node, this will be 3, this will be 3, but this will not be 3 because the base value where we started was 1. After completing, our array would look something like this, and our image would look something like this. You can see only horizontal and vertical nodes were affected from the initial node. This cluster of 1 is still the same, because though it was a neighbor of earlier one, but it was not a horizontal vertical neighbor, but a diagonal neighbor. This is the solution for the flood fill problem on LeetCode. In this step, I'm declaring m and n. M is the vertical length of the array, n is the horizontal length of the array. In variable c, I'm storing the initial color number that is stored at the coordinates SR and SC. In our example, which is 1. In this if block, I'm checking if the initial cell at SRSC is already equals to color. In that case, we don't need the flood fill operation, we'll simply return the image. This is a recursive function and its call. This function is using DFS to fill any respective area in the image array. I remember in my analysis, I said that flood fill operation used BFS, but DFS works just fine in this case as we're just filling up the cells and we need to only traverse them once. So the overall time complexity between BFS and DFS for this case remains the same. And there is my personal preference that DFS is a little easy to implement. This case here in if block ensures that we do not cross the boundaries in our image array. And this case ensures that we do not visit the cell that we have visited already, saving us from an infinite loop. This line converts the color of the cell from the initial color to the destined color. And these two are the recursive calls to cover 4 directions of vertical and horizontal neighbors. And after performing the operation, we just return the same image array.